Hello, everyone. Welcome to chapter 5 of 6. You are almost there. Um, Chapter 5 is uh, another good chapter in terms of just kind of general understanding of how we can evaluate and summarize data. Um, and uh, and so chapter 5 is going to talk about scatter plots and correlation, but we're going to go into it a little bit more than you probably have in other math classes. But that's going to be kind of the theme throughout the entire chapter. So scatter plots and correlation look at the relationships between two variables. This is a very common practice in studies and things that you might hear about in the news. If you've seen the movie Moneyball, which at this point is actually getting to be pretty old, but that movie is about a baseball owner of the Oakland Athletics who wants to try to find the best way to win games, which is obviously the goal of everybody, but to do so in a more or less the cheapest way possible, which is why it's called Moneyball. And so, what he ends up finding, or what his team of researchers end up finding, is that it's not actually the amount of runs that you score that's the best correlation. It's OBP, which is how often you get on base percentage, has the best correlation in how to win games. And so that kind of took the baseball world by storm. That was a pretty big trend for a while, and it kind of still is, to focus not necessarily on how many runs can you score, but let's just get on base and see what can happen. A lot of health related issues are looking at two variables. So obesity compared to diabetes, is there a correlation there? Obesity versus heart disease, and just a lot of different health related issues there can be found. A lot of the issues have some lurking variables in the background. So, for example, speaking of like diabetes and heart disease, you could be as healthy as an ox, but if you have a family background with either of those in your family history, then you are at a higher risk just because those can be hereditary. And so we call those lurking variables. Those are things that are kind of in the background that, for the most part, are going to be out of our control. One thing to make sure is that you have your graphing calculator with you when you go through these videos. Again, gone are the days where we do a lot of this by hand, so we're going to be using technology, and specifically we are going to be learning how to do this stuff on our graphing calculators. But scatter plots show the relationship between two quantitative, we defined that word back in chapters 3, I believe, two quantitative variables measured on the same individuals. And each data point appears as a point on the plot. And so making a scatter plot, fairly simple. Plot the data, look for any patterns and deviations, and then if possible, let's try to summarize. So I have an example here of a scatter plot. This scatter plot is data that was collected to try and estimate when Old Faithful will erupt next. Old Faithful, if you are blanking on what that is a geyser in Yellowstone National Park. A geyser is, I guess I don't know the technical definition, but it's basically a water spout in the ground, and every once in a while it spouts up, or it explodes, or it erupts. In fact, we have the data here to see how often. So if we look at our data here, on the x-axis, the horizontal axis, we have the duration in minutes. So this is how long the eruption lasted. On the y-axis here, we have the interval. This is how long there was in between eruptions. Okay, and so it looks like, for the most part, we have two strong clusters here. One kind of in this lower left corner where it looks like a lot of the eruptions are right around 2 minutes long. And then we have a little bit of a gap. There are some random ones here in the middle, a little bit of a gap, but otherwise we have another cluster here at about 4.5 minutes long. And so I'm just going to kind of explain. I'm not necessarily going to write all of this down, but if we just talk about the data and any patterns that we see, it looks like as the duration gets longer, the interval in between gets longer. Okay, And if you think about this, so basically what a geyser is it's something below the Earth's surface. It fills up with water, and at some point it gets full enough to the point where it explodes. So this kind of makes sense, where if it only lasted 2 minutes, it's because there was less water in it. In between eruptions, it didn't take as long to fill, so there was less water in it, meaning the eruption itself was shorter. On the other hand, these eruptions were longer, and it's because the interval in between was longer. So again, it had an extra 30 to 40 minutes to kind of fill up with water before it exploded. And so we could use this data. What we will learn how to do, not exactly with this data, but we could use this data to then predict how long it's going to be, right? If you are at Yellowstone National Park and you're there to see Old Faithful erupt, you don't want to 105 minutes. That's over an hour and a half. You don't want to stand there for an hour and a half and waste your time while you could be walking around. And so we have a way to try and predict. Of course, it's not going to be perfect, but try and predict that. And that's part of what we learn how to do in Chapter 5 is take data and make predictions off of it. One thing I do want to talk about on this page is these deviations. So deviations is just another word for outliers. Are there any outliers in our data set? And when we're just looking at data where we don't actually have it in front of us, remember from chapter 3, we learned how to calculate an outlier, but in this case we don't have the information to calculate it. And so if we just kind of give it the old eyeball test, I would say that point right there is kind of an outlier off by itself. Maybe this point, maybe these 2 points. Otherwise, it's mostly clustered together. Even these points in the middle, I know they're a little bit further spread out, but if we follow kind of a rough pattern here, if we were to draw a line of best fit, which again is what we'll learn how to do more accurately in Chapter 5, those points in the middle, these points right here in the middle do follow the pattern. So they are not outliers. It's just not super common, it looks like, for the Old Faithful to erupt for 3.5 minutes. But those points do follow the pattern. Okay. Again, right now we're just using this as kind of an eye test. We'll learn how our calculators can help us with that a little bit later. So there are 2 types of variables when we're talking scatter plots: a response variable versus an explanatory variable. And I ask you just to think about why they would be named those. And I'm going to kind of actually go out of order. An explanatory variable is something that we think explains the response variable. And then the response variable is the response to the explanatory variable. Okay, so we kind of talked about this on the last example. The duration is your explanatory variable, because it seems like the longer the duration, the longer the time is in between. Okay? So the duration explains, that's why the duration is the explanatory variable, the duration explains the interval of the data, or of the eruptions. Okay? Now, there will not always be an explanatory versus response distinction. Oftentimes there are, and it's cause and effect is basically what we're talking about here, where the explanatory variable is your cause and the response variable is your effect, is basically just another version of what we're doing, what we're talking about here. And so, looking at another example, comparing the weight of 8 students and the weight of their backpacks, and in particular, the resource I got this from is talking about 8 people going on like a hiking trip, and as you would need on a hiking trip, you bring a backpack full of stuff to camp overnight, and so each person was assigned a particular backpack. Okay, and if we think about this, if you are in this group and all the backpacks are just kind of general use, so you didn't necessarily pack your own, but you are going to carry just stuff that the whole group needs, one would probably look at the group and look at the biggest person and say, you get the heaviest backpack. Look at the smallest person and say, you get the smallest backpack, and kind of work their way in between that way. So in that case, when we're trying to figure out explanatory versus response, your body weight explains the backpack that you get. So in that case, then the body weight is the explanatory variable. The backpack weight is the response variable. And again, think of it quite literally. Your body weight explains the weight of your backpack. Okay, so body weight explains the response variable, the backpack weight. Okay, so here's what that data looks like graphed. Again, later we will learn how to do this on our calculator. But here's nonetheless what that looks like when it's graphed. And so we have our scatter plot. Body weight, again, your explanatory variable is always on the x-axis. Your response variable is always on the y-axis. So body weight is horizontal, pack weight is vertical. And it looks like we have a pretty good pattern here. It looks like there is a little bit of an outlier, right? It looks like the heaviest person in the group is carrying, maybe the third lightest backpack. But other than that, it pretty much follows a decent pattern, okay? And so in terms of any patterns, deviations, and summarizing the data, the heavier the person, the heavier their backpack is going to be. Are there any deviations? Yes, it looks like the heaviest person in the group is the, sorry, I lost my train of thought. The heaviest person in the group is not carrying the heaviest backpack, so that would be one outlier. Otherwise, they all kind of fit a general pattern. Okay. So last thing before we wrap up 5.1 and 5.2 is just practicing this idea of explanatory versus response. Now, I know that what you have to get away from is, I know it's not always perfect, right? Again, we just saw there are outliers. And so specifically, let's look at the first one, because I know we've all experienced this. It says the amount of time studying and your test score. We've all experienced this where we feel like we put in a ton of time in studying for a test, and then our test score isn't what we wanted it to be. Okay, and so again, there are always outliers with every scenario. In general, though, the amount of time that you spend studying explains your test score. Again, in general. Not always, but for the most part, we would be able to see a pattern. And if you did put a lot of time in, you might have done better than somebody that didn't put any time in. So, again, I know we've probably seen both sides of this, where it's been really good, and other sides where it hasn't followed that pattern. Okay, but in general, your time studying should affect your test score, both negatively and positively. Height of a person and their weight. Again, there are always exceptions to this rule. That said, in general, your height is going to be an explanation of your weight, at least partially. Okay. Again, there's always exceptions to the rule, but in general, we can say that your height will explain your weight. I know you might not know anything about farming and growing, but we can use some common sense here that if it rains a lot, that is probably good for farmers since they rely on rain to water their plants and they don't have to water themselves. So the less rain that they get, they might not experience as good of growth in whatever they're growing. In this case, it says inches of rain during growing season and the amount of corn in bushels per acre. Again, I would think that the amount of rain that you get is partially explanatory to how much corn could be produced in this scenario. And again, there isn't always explanatory versus response. So scores on an SAT math test and scores on an SAT reading test. How you do on the math portion of the SAT does not impact how you do on the reading portion of the SAT. Now, one pattern that you might kind of find and think is that, well, if you do well on the math test, maybe you're just smarter in general, so you're going to do well on the reading test, or vice versa. But again, we can't definitively say that one explains the other. In fact, in that scenario, your knowledge would explain your scores, but the math test score doesn't explain the reading, and the reading doesn't explain the math. And so in this case, there is no designation. Okay, so there might be a pattern. Okay, again, if we have this data in front of us, we might see that just because maybe you're smarter, that your math and your reading scores do form this positive pattern. But Again, that doesn't mean that math explains reading. That just means that maybe your your IQ or your knowledge level explains both scores. Okay, so there's no correlation between these two. Even if you might see, I should say, there's no direct correlation between these two. Even though you might see, a graph that looks like there's a pattern. Okay. So again, this is not 5.1 to 5.3. This is 5.1 to 5.2. You'll need your graphing calculator moving forward for the next couple of videos. You'll be asked, we'll be using that body weight example off and on throughout chapter 5. So just kind of a heads up on that. But before you start the next video, make sure you have your graphing calculator with you.